Hey there, everybody. We're going to try a car video today, see if we can get one of these going on the run. All right, we're talking today about Francis Bacon and the rise of science. Now, I love me some Francis Bacon, all right? Francis Bacon is awesome. So let's recap or remind ourselves, perhaps, where we're at. If you recall, the Protestant Revolution was in full swing at the end of our last presentation. We find that the church is starting to get questioned. So the church dogma at that point, is in particular Christian church dogma, consisted of some truths. Here's just three of the truths that we're going to kind of lay out. The earth is the center of the universe, okay? They even had scripture for this. The heavens will not move. I don't even remember what it was, but they had some scriptural proof about this, all right? There are exactly 7 heavenly bodies in the solar system because that's how many were reported in the ancient literature. Remember, we had already said that Ptolemy, the ancient Aristotle's works were cited as facts. And Aristotle knew of 7 heavenly bodies, therefore there were 7 heavenly bodies. To say anything else is heresy. Okay? And humans were created in God's image, okay? And so as information was found, these truths started to be challenged a little bit. And the more things were challenged, the more challenges came about, okay? Say, for example, reasoning was used for, Aquinas had already said that you could use reason and examination of nature as ways of knowing God. That's right. He already opened the door on that. So along comes one of our favorite players in this whole game. Hey, I see you. Sorry, Ptolemy. Ptolemy is actually one of the ancient players. He's a guy. He set up. He hung out with Alexander the Great. It was an awesome scientist. He, in fact, set up what he called the Ptolemaic system, which is the one which put the Earth at the center and explained things. It was interesting. It was a useful system, putting the Earth at the center, or geocentric. It was useful because observations at the time really matched it. And using the assumption that the Earth is at the center, you could make predictions, okay? And not only that, but it was convenient because it made human beings special somehow, because we're in the middle of it all. But later on, Copernicus. Now, Copernicus, first off, you got to know this. This is an interesting thing. So many of the major players, whether they be the philosophers or the scientists of this day, were very diehard Christians. And they discovered truths that they saw were hurting their church, and they didn't want to say them. They did not want to do them. So Copernicus he's a mathematician, a mathematician. He was a church canon. I mean, he was really an astrologer. Astronomy was just a hobby of his. It was just something, he was a backyard astronomer. And he came up with some observations. And here's the deal, okay? In his observations, what Copernicus found was, in fact, it was a kind of an interesting little side story. It turns out that, Copernicus came to see, here's the problem. Until somebody got out in space and could actually see things, there's no way to know for sure whether the Earth is at the center, okay? So we didn't know about Copernicus' theory, know it was true until the 1960s, until we could throw up a satellite and take a picture and see it. But what happens is that even though under Ptolemy's geocentric system you could make predictions, it turned out that the math was quite complicated. In fact, one of the greatest problems of the early Christian church, pretty straightforward, was the church elders, church leaders, in particular the Pope, was very, very bothered by the fact that they were worried that they were calculating Easter wrong. Okay, because Easter is by far the holiest day on the Christian calendar, And it's quite a complicated thing to figure out, because it turns out that Easter is based on, let's see now, Jesus went into Jerusalem on the Passover. And so the entire calculation of Easter is based on the Jewish calendar, and the Jewish calendar is a moon calendar, okay? And so all of a sudden this funky lunar calendar has to be merged with this funky solar calendar, and the solar calendar is wrong, by the way, because it's at this point in history they still haven't exactly completely figured out about the whole leap year thing, right? So they're trying to calculate all this stuff, and the popes for 200, 300, 400 years, they felt that the worst sin that they could possibly have would be to calculate Easter on the wrong day, because that would guarantee they go to hell. Okay, a pope goes to hell if he can't figure out Easter on the proper day. Well, Copernicus, so the math involved was really complicated. But that is to say, if you assume that the Earth is at the center, the math is really complicated. But if you drop that assumption that the Earth is at the center, and you look instead and say that in the solar system the sun is at the center, all of a sudden, guess what? The mathematical calculations become a boatload easier, so much simpler. But you can do it with the old system, don't get me wrong. So when Copernicus writes his book about this, he actually dedicates it to, see, he didn't publish it in his lifetime. I want to say it was Galileo that actually published it after Copernicus's death, because Copernicus did not want to do this. He did not want to publish this. But what he did in his book was he dedicated it to the Pope. And he wrote a little note at the beginning, at the forefront, that said, this book is dedicated to the Holy Father to help you solve a generations-old problem, or something like that. And so it was a gift. It was a gift given to the Pope. And at first, the Catholic Church says, this is great. Oh, my goodness. No more popes are going to go to hell for getting Easter on the wrong day. But guess what? They started to read it. And they said, oh shit, we're not at the center? Wait a minute, God loves us. We're special. How can we not be at the center? How can we human beings, us egocentric human beings, not be in the middle, okay? And so all of a sudden it's like, okay, wait a minute. If God didn't put us at the center, then one of the major beliefs in the church is not true. So is there other things? Is there other solar systems? Does God love them? I mean, what the heck does it open up? What am I doing there? Alright, so along comes Galileo. As I said, Galileo, I'm pretty sure it was Galileo that actually published Copernicus's work, but it doesn't really matter. Galileo, just as an interesting little side note, Galileo did a lot of stuff, but he put together the first telescope, and he shows his telescope, and he uses it to show that there are more than 7 heavenly bodies, right? Check it out. You can see more than that. And some of these people that were looking into it said, no, Galileo, no. The thing that I'm seeing is inside your telescope, not up in the heavens. And they accused Galileo of planting the images inside the telescope so that it would look like there was more than 7 heavenly bodies. Alright, that's lovely. So, what did Galileo come up with? Some pretty genius things. The universe is a perfect machine which worked on mathematical principles. Now, I love this. Mathematical universe, okay? He writes, we need to understand the mathematical reality that exists beyond the world of appearances. Some fancy words, but boy, that better bring back memories of Plato, okay? Plato, remember, talked about the imperfect world that we live in, like the imperfect world where every dog is different, and the heavenly forms where everyone is the perfection, the truth. The truth is up there. Remember, in fact, the Pythagoreans and their Pythagorean theorem, in theory, the Pythagorean theorem is perfect. In truth, it never actually works. And so this is what Galileo emphasizes, okay? He felt that you needed to do experimentation for 2 reasons. One, to establish what the physical laws are, because they're there. But perhaps more importantly, to demonstrate to people that were skeptical about them. Okay? And so here's a rehash on something that I had mentioned in one of the other presentations. I don't remember which one. And remember, in fact, I had used the phrase, if a tree falls in the woods and no one is there to make a sound, no one's there to make a sound. Ha! If a tree falls in the woods and nobody's there to hear it, doesn't make a sound. And I had said, look, okay, the tree does in fact exist. That's a primary quality. Take a look at this slide here. The existence, the mass of the tree is a primary quality. Other examples of primary qualities: size, shape, number, position, and movement. Okay, these exist without a perceiver. Does it make a sound? The answer is no. Those are secondary qualities. Those apparent attributes of physical objects that in fact only exist in the mind of a perceiver. Okay, they only exist in the mind of the person that is perceiving it. And so, I just said that. It's really complicated in a car, all right? And so, according to Galileo, most conscious experience consists of secondary qualities, not primary qualities. Secondary qualities can never be described and understood mathematically, he says. Therefore, consciousness can never be studied using the objective methods of science. By definition, psychology cannot be science. That's what Galileo said. This might be an interesting response to that. Reaction paper 1, I believe it was, is psychology science, okay? All right. And then along came Newton. And Newton did a lot of things, but he took, what I really want to focus on is what he took on Galileo. And he said, okay, well, I mean, Newtonian physics, there's 3 laws of motion, an object stays at rest, etc., etc., universal laws of gravitation. And in fact, what Newton did was he expanded those laws that describe, say, for example, if I put a ball on a hill, how does it roll, or something like this, and he used the same exact laws to describe how planets moved, okay? In other words, the same laws that exist, that work in the heavens, also work here on Earth. They're the exact same laws, okay? And same as Galileo, he felt that the universe was just a giant lawful machine. I mean, the ultimate in determinism, all right? The ultimate in A causes B causes C, all right? What happened is Newton's belief really, and again, I want to emphasize that Newton was very hesitant to publish this stuff because he also was a very, very firm Christian, and he found that his beliefs just weren't matching what he what the church was saying, because it's sort of his belief that the universe is a giant machine and this ultimate determinism. And again, I also mentioned this one at one point in another presentation. It removes a need for God. You don't need God in this description anymore, except God hit the start button, and once the start button happened, it all was just preordained, right? Which explains how God is, of course, omniscient. Alright, God is omniscient. Hello, there it is. Alright, so God is a creator, that's it. Didn't need anything after that. Material world is governed by natural laws, the same laws that describe the universe. Natural events do not occur because of properties in the objects. It's not. The keys do not fall because some property inside of the keys, but instead it is a property of the universe, or the stone falls. There you go. Occam's razor is to be accepted. We didn't mention Occam's razor, I did not mention in the video portion, but it was definitely in the notes. I saw it in the notes. Occam's razor is the basic idea that the same reason that we accepted Copernicus, in that simpler explanations are almost always better. Almost always, okay? So, natural laws are absolute, says Newton. Yeah, we don't understand them absolutely, but that doesn't mean they're not absolute laws. Okay? Then along comes Francis Bacon. He's one of my favorites, okay? I want to tell you a little story here. This is, the details elude me, and it's in the full PowerPoint lecture if you look into it, on the notes underneath. it tells the whole story. I don't have the whole thing. But it went like this, something like there are 3 monks and they're standing around and they're talking about the number of teeth in a horse's mouth. And they say, well, Ptolemy had nothing to say about the horse's teeth, so I don't know. And so the other monk says, yes, I looked through all of Aristotle's works, and there's not a single place in there that it says anything about the number of teeth in a horse's mouth. And the third monk comes up and says, I went through the Bible, and you know what? I just couldn't find anything in the Bible about how many teeth are in a horse's mouth. And then along comes this young monk, young little upstart, and he says, sirs, can we just open the horse's mouth and count them? And so they smote him on the head. You got to read the thing. They smote him with a staff and mightily and something. I don't know. It was a neat little story, right? Dude, open his mouth and count them. And that's what Francis Bacon uses as an interesting story to describe what his world had become. Okay? What his world had become and what was wrong with it. How knowledge was just these assumptions that we have take away. And so Francis Bacon felt that any time that you have an assumption of any kind, you're going to make a mistake. Okay? He demanded science based on induction. Using induction, what happens is you look at thousands of cases and then figure out the general principle that ties them together. Okay? With deductive reasoning, you start with a theory or something and then generate observations backwards. Deductive reasoning starts with an assumption or a theory. Therefore, science should contain no theories, he said. Okay? I disagree a little bit, but I see his point, okay? Because these assumptions will guide what we look for, okay? They will guide how we search. If we assume that the answer must be in Aristotle or the Bible, then we will never find the truth because we have gotten mistaken assumptions to begin with. So, here's the deal, says Francis Bacon. Science's job is one, make the world a better place. That's it. That's the only job of science, make the world a better place. Okay? Science can improve, furnish a knowledge that would improve technology. Very, very briefly, Francis Bacon dies. I mean, he's just this hero, right? One of my heroes. And here's how he dies. He's doing an experiment to find out the effects of refrigeration, basically. There's no refrigeration at this time. He wants to know the effects of freezing on meat preservation. So he gets a turkey, he stuffs him full of snow, right? And he stuffs it full of snow to find out if it would make the meat preserve better. And he catches a cold in the process. He catches a cold from playing in the snow, and he dies. He dies from a cold that he catches from stuffing turkeys with snow. Not a noble ending for a noble fellow, okay? But here's the deal. He said there's 2 kinds of research. This is a big deal here in modern psychology. There's basic research versus applied research. Basic research, called experimenta lucifera, okay? They are experiments of light. These experiments of light are those research that are done to discover the basic principles. Experiments of fruit are those where you try to make the world a better place. Applied research. But in order to do applied research, experiments of fruit, change the world, make the world a better place. Look at the top line. In order to make the world a better place through applied research, you must first have established the basic principles using basic research. Scientific activity should be supported by public funds. That is so true to this day. Here's the deal. Applied research is funded by whatever institute is going to benefit from it. Okay? Because applied research implies that they're going to make money from it. However, in order for that drug company to be able to do the applied research to test whether a drug works, somebody somewhere had to do the basic research to establish how these chemicals combine together. And those drug companies most certainly are not going to spend money on basic research trying to figure out the basic principles of chemical interactions. Their job is to just make money. Okay? And so them freaking drug companies only make money off of the backs of somebody else before them. And you know who pays for that basic research is the federal government. In our country, it's usually the National Institute of Health or some derivation of it. NIMH in psychology would be more likely, but some version of public funding is always used for basic research. Then along comes Descartes. Now, I don't like Descartes very much. He's not my favorite player. He confuses me. He makes my brain hurt. But I will give you a couple of slides on Descartes. Okay? Descartes did a lot of thinking. All right? He didn't want to leave his home. He changed addresses a bunch of times because people found out where he lived and he didn't want to be bothered. I mean, this dude is crazy. He just lays in bed and thinks. Now, he says, look, I have some ideas in my mind that are perfectly clear, okay? And yet, there's nothing in my experience that could possibly have put it there, like God, okay? I have an idea of God in my head, yet I have never in my life had a physical experience of God. So, where did it come from, okay? He said, look, I mean, this must be what we call an innate idea. Granted, this is going to be the foundational principle of the rationalistic philosophy in 2 chapters. Okay, they must have been put there by God. In other words, the axioms of geometry, God, infinity. What the hell is infinity? There's no possible way you have ever had an experience of infinity, yet you can have a clear understanding of infinity. Now, how is it possible you can have an understanding of a concept and yet never have ever experienced a concept? Well, because they are innate. When was this? I don't think I care. Well, intuition. But anyway, he's setting the groundwork here. Intuition, basically setting the groundwork for the use of introspection. And this will be picked up by a lot of later players, but like I said, I don't like Descartes too much. So he created a mechanistic explanation. If you look at some of his stuff, he was in fact very, very inspired by. I still remember this story. He was walking in the gardens at the Palace of Versailles in Vienna, Austria, right? And he's walking through the gardens. And they have these little streams, and as you're walking across through the garden, you step on a stone, and the stone is actually a switch. And when you step on the stone, it pushes down, and it opens a little stream, lets water through a pipe, and then the water goes into like a mechanical creature, and the thing dances around because the water's moving through the pipes. And Descartes saw that, and saw it as a very good analogy to how human beings work. And he clearly set out the idea that, and started the groundwork, which we'll talk about more in the rationalism and empiricism and stuff. He sets the groundwork. He says, number one, humans are machines, period. You know, the laws of physics, they also describe the human body. Okay? But he also has set up some interesting mind-body situations. The brain mediates between the mind and the body. He sets this up. He sets up some dissection studies. He already starts the groundwork for later players who are going to come out and say, some wacky balls, man, that even ideas are physical entities, and therefore physical entities subject to the exact same laws. Remember, going back, Newton says the universe has laws. The universe has laws to describe planets. He brings it down and says those same laws describe how an apple falls from a tree. Bring it further. Descartes says, yeah, but these same laws that describe all of that shit also describes our human body. Take it further up into the next, I want to say it's the rationalist. Taking it up further, they even say, look, even ideas have physical existence, and therefore these ideas are subject to the same mechanistic things. In other words, what we've set up here is the absolute foundational principles for determinism that science requires. In the next chapter, we're going to talk about empiricism, in particular John Locke, but some of the other major empirical players as well, and we'll move into rationalism after that.